It is nice to have so many people, even in the afternoon. And yeah, this is not a particularly technical topic because I won't be talking about really much technical details, but rather what developing a package could bring you as a team when you're working in a company. And first of all, hi, I'm Andrei. I am core developer of open source time series forecasting package called Etna. Etna is not developed by SML. It was developed by my previous team when I worked where I worked previously, but it doesn't really matter because now it's open source library. And why do we have packages? And before I start talking about my experience, I'd like to clarify some details, add some definitions. By package, we usually mean a box of frequently used features and classes and like something like that. But it is not particularly true because we also introduce some complexity, some abstract models, some set of rules. So this package will be easier to understand by external users. And we create those rules for solving a specific tasks. And yes, basically every package is unique because it is designed to solve different tasks. It could be focused on tasks like solving forecasting problems, or it could be like scikit-learn, really broad way of usage, really common package that could be used by many developers for many problems. And we also could have different methods in our package, like in scikit-learn. Scikit-learn has a lot of models, a lot of algorithms, like basically you can do anything with it if you try hard enough. But you also have packages that have very specific methods. For example, PyTorch forecasting package has only neural networks to solve really specific tasks, solving only forecasting problems, only time series. And XGBoost, for example, yes, it has only boosting models, but it could solve really different tasks with it. And the idea is that all of these packages have different abstract layers, abstract models, set of rules, how they're written, and everything. And we should also have to keep in mind that. And how to make a package. And I'm not saying about making a package like as a person, because as a person you may have a desire to write a package and you basically there's no one to stop you from doing that. But when you're working in a company as a team, you have somehow to justify why would you need such a work. And in my opinion, the best business structure to create a package is when your team, your machine learning team, is in the middle of everything. Like you have different business clients coming to you asking, like, we need to create model, we need to create data pipeline, and like they coming to you asking you to solve for them different, I don't know, machine learning data related use cases, and you provide them with such pipelines, with such models. And in our cases we just collected our use cases, and basically all of them were about forecasting something. We either forecasted some phone calls, deliveries, or service requests. And even though we had different models, different steps in our pipelines, basically we did similar things over and over again. And if we decompose them, we could really construct an abstract model that says us, like, you have this step, after that you perform this step, then you apply machine learning model, then you do your validation and putting it in production. So it somehow we got an idea that maybe we could a bit automate this process, make it easier for us. And we also got our requirements not from our use cases, but also from inside the team, because it is really important. Because when you develop in a package, your team is the first user of this package, and basically you need this package to be as much comfortable to use as possible, because you're basically a developer of this package and a consumer at the same time. And yes, below the requirements, I have like this mental model, abstract model of how our forecasting pipelines usually look like. And after that, you should just start writing everything and start writing your drafts, putting every step in the right position, every step of your different use cases, of your different pipelines in the right position. And at this point, you really have to convince your project manager to believe in you, because you're spending time on doing things that already is done, and you have to convince this person who gives you time that this work is essential, that this work could be beneficial not only for the team, not only for the developers, but also for business. And when you do that, well, you could actually add more features and it will be easier than before. And what are the benefits? How we convinced our project manager? Basically, we said that, well, all the use cases will be equally tested, because you write this package, you test this function, this class, and you use it across different pipelines. And after that, whenever you use it once more, it is already tested in the package. Everyone in your team will know how to work with this package, because everyone at some point will participate in development. They will have some understanding how this is built, what abstract models we use, and it is actually a good idea to have all this collective effort put in one place and not put in different pipelines across your team. And this will result in faster and better deployments, because actually you can, when you have a new use case, you can basically apply an old pipeline to the new data, and probably the more use cases you have done previously, the high probability that this result will be really good enough. And also, after we build this draft, after we build it, we also got some unexpected benefits. We did not expect that. Basically, we stopped writing Python code for our new use cases, because we had configuration files. We just specified input data, output destination, the whole pipeline as a YAML config file, and we had Docker image with a library that could read this file and produce a result. Basically, it was easier than before. And also, we had similar logging strategies across all the different use cases, and we can easily find the source of the problem. And for example, if you also use some log aggregation services, it is easier to query those logs to find these problems, to calculate metrics on your pipelines, to see how they perform. Basically, it was good enough. But this always seems so good on the slides when someone presenting to you that we did great on the first try, but no, that's not how it looks in real life. Basically, we did not great in our architecture, and we introduced a bad architectural pattern called the get object. Basically, that's how it looked like. When we had a small amount of features, we had this small class called data handler, which should have ring the bell even at the time when we created class called data handler. What does it do even? I don't know. But no, we were not as experienced back then, and the more features we added, the more code we should have added to data handler. And when we changed code in our data handler, we have to change code that were previously written in other pieces. And the more features we added, the more time we had to spend on adding more on adding all these changes across all our code base. And at some point we thought maybe refactoring is not such a bad idea, but we were satisfied with our not architecture, but we were satisfied with our functionality. The business liked how we work because we could faster intake new use cases, but for us adding new features were like really painful. And we come to the product manager and ask for some time to do the refactoring. And because we didn't done good previously, we were allowed to have time to do the refactoring. And we actually looked at the architecture, decomposed them, like we saw exactly what parts doing what work, and trying to construct a better abstract model. And I have an advice how to do this perfectly. Basically, you should put time and effort in this process. There's actually no silver bullet here. Like, you should do a lot of brainstorming with other people, so your ideas will be tested against like reality. You should actually learn design patterns if you haven't done so at university. You should also write some drafts to see if this idea is actually working, and do that over and over again until you're satisfied with your work and you could explain to other people that it really makes sense, because at some point you will be so caught up with your ideas that it will look like a good solution, but in reality it won't work. So you have to include other people in it. And yeah, basically after the refactoring we got this actually the same pipeline than before. We had like exact same steps, but because we made our library cleaner and easier for us to develop, we were able to introduce even new module called analysis that allowed us to plot results, plot metrics, like analyze the time series. And the benefits of all this work done, it was a long process, because we were not only developing and refactoring, but we also were adding some new features, is that we actually had a proper unit tests across all our code base. We had an onboarding documentation for new users, and most importantly, because we did this deconstruction of our use cases, of our architecture, of how we use and write code, we gained a better domain understanding about time series. Business, on the other hand, got faster intake of new use cases, and also they got an idea that if they have some problems with time series, so they want to forecast them or analyze them, they could come to us because we know our stuff. And actually that was like beneficial for both parties. But actually, when does open source come into play? And I don't have any idea how that happened, because it was just an idea that maybe we should open source a package. And management said, why not? Let's test this idea to see what will happen. And we open sourced it. And by using this QR code, you can find this package and also my contacts. But also, again, if you're working with time series, because the package is only focused for time series forecasting, and the presentation is not about creating a time series package, it's about creating like any package. And yeah, but what we gained by open sourcing this? but by open sourcing our work. Actually, we gained even better documentation because now we did not have to explain us what the package is capable of, but to explain other people why they should use our package to work with to solve their time series problem, how this package is constructed, what parts does it has, and does it have, and basically like everything. And yes, it requires a lot of work and effort to build the documentation, but the onboarding process for new team members is as easy as possible as it was before. We had to create better processes, like explaining what this task is about, explaining how a code review is, how code review process is going, and also we had to create like many CI/CD steps for our pipelines when we do new releases, when we add new features. We actually have to write a lot of tests to see if this will work actually. And you start write better code, but you start using doc test, you start using linters, formatters a lot, and even signature linters. That's the best, I guess, because they see that your documentation is connected to the signature of the function in reality, and not that. Yes, function has documentation, well, it's fine to go. No, it checks if all the arguments is there. And what we got in return, well, actually GitHub stores, which is really satisfying process. I don't, like first few weeks, you just constantly reload the page and it's like, wow, 10 stars, I'm popular. Sometimes people will actually commit something to your library, like once a month or something, and your PR department in your company could also use this to make hiring process easier, or to use something for, I don't know, for example, we forecasted how many flowers will people buy during St. Valentine's holiday, for example, and they published an article about it that was cited by like every media in a country, I guess. And also it is easier to communicate with the community as well, because now you not just working for a company but also developing something, and people start talking to you voluntarily. You don't have to force them to talk to you. But yeah, it's actually feels really different, and you could share the ideas, and that's important in development, I guess. And well, in conclusion, even though we open source the package, it's not a philanthropy, because the company also gains some activities. They're not like instant, they kind of work in the long run, and package development also works in the long run, because like you have to spend several weeks, months developing it, but in a long time it will allow you to work faster than before. It also makes processes better because you include every member of the team into these processes, and they share the ideas how to make them even better, and that's good. When you compare it where usually like team lead thinks of processes and you kind of maintain those processes, but you do not, but you're not in the loop of improving them. And ironically, this package development allows you to spend more time on code, because one code block now is more important because it's used in different pipelines, and you have to test it more, you have to make sure everyone in the team understands it, you have to add documentation, you have to make sure that it is not like have, I don't know, 10 for loops, for example, I don't know. And also some unexpected benefits. For us, it was about configuration files, Docker containers, and logging. And for other, I don't know, teams, it could be about anything else. And I guess to experience these unexpected benefits, we just have to give it a try writing our package. And that's all for me.
Wow. Yeah, I think this was really an inspiring story. Thank you. I was just curious, how long did it take you to move the package from like in-house to open source?
1 year.
Oh, okay. Yeah. So yeah, quite a bit of work, but
Yeah.
I guess it pays off.
Well, it was not about development. Like development, the first draft took me about I don't know, one and a half month. And then we added some new features. Then we had refactoring time again for 1.5 months, and then we open sourced it. So
very cool. Are there more questions from the audience? Yeah.
Thanks for your talk. I do have a technical question.
Okay.
What is your package building program? Is it Flit or Poetry, and why? just interested.
Well, we use Poetry because it really nicely solves these requirements. We really like that, and it also allows to like build the package easily. And well, that's just a nice package. I really recommend it.
How did you get all your stars? So I see you've got 649 stars.
Yep.
I'll give you one. I'll give you a star if you answer the question well.
Okay.
I'm curious. So you build a great package, you put it out there. How do you get people to start using it?
Basically, that's I guess that's a topic for even one more presentation, because it's after the open source in the package, it's not about the development of the package anymore. It's about communicating with people using it, like describing how to use the package, releasing maybe some articles about it in Medium or something like that, coming to the conferences like this. So you will give us a star, and maybe other people also will. That's how we gain the stars. Yeah.
Thank you.
Yeah, thank you. I have a question. You said you had you started while incorporating use cases from the internal customer, from internal business. And from my experience, this means that you have a lot of data wrangling and like customer business specific code in these pipelines. Did you remove that from like this specific data wrangling part from the package, or is it included, or how did you approach that?
Well, when you start merging different use cases, you actually find out that the data for different use cases looks quite different, and you have somehow to standardize it. And when you standardize it, you kind of remove all the details about the data itself. So basically, there is no case-specific details in a package, because otherwise it wouldn't work for other use cases. I hope I answered your question. Okay. And there's one more question here.
Thank you. Yeah, so you mentioned an architectural anti-pattern, right? The God object. But
yeah.
So, and you also mentioned, I believe, but correct me if I'm wrong, that you partially solved that by engaging in this brainstorming process and this iterative process. I've experienced the exact opposite, where we had these anti-patterns, engaged in that process, and it became much worse. So I am not fully convinced that that is the solution. So maybe we can dig a bit deeper into that. So what specifically did you do to get that on track?
Basically, yes, you have to have someone in charge of this architecture process, but then this person should align with the other team members to validate his ideas. Even so, you have not only brainstorm together, but also come to a conclusion and brainstorm over like your ideas to find like weak points in it.
How does testing factor in? Like, when do you test, and because you say you need to validate, right? That sounds like testing to me. So how did you approach that?
Basically, you try to construct some use case with your new model and see what will happen if we add like more features, or if we add if we throw in like, I don't know, more models, and if our pipeline is very long, like we have I don't know, 100 features, what will happen to the code base? And basically, like you look at different use cases, you try to find at this point this could go wrong. For example, if you have need to add like new model to some category, to some class, to some other class, that means that it's tightly coupled, and at some point you will have to refactor it again. And also when you work with different models, they have different like inputs, different parameters, different everything, like for example boosting models, profit models, and neural network. And when you solve this with some other class that will handle all this work, and not by an abstraction model, for example, what you like wrap your model, and that means that it's kind of bad situation, because you will actually create one more this GAT object.
Little bit of a follow-up then, and how did you prioritize what to test? So which validation was most important? How did you figure that out with your team?
Well, basically we figured out that each class should not look into the internals of any different in any other class, and it should only expect input as a data and output as a data, and nothing more.
Thanks.
So now you have a package and you have a community using it. Do you have a long-term contingency plan? How do you make sure that if for example, your employer loses interest maybe in the package, or the package becomes less essential to your work, how do you make sure it stays alive?
Well, that's a hard question, because there's no right answer, and at the moment I don't really have like any long-term plan for supporting it. But I think if the community finds this package like important, it will, and at some case try to keep it alive. But yeah, that's an important question. Yeah.
Okay, thanks.
So, if there are no more questions, please give him a last round of applause and some GitHub stars.